Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of hypothesis testing. I'm going to do it by looking at two different methods. Choose whichever method applies to you and try to understand both of them, because different groups of people will decide to use different things. So in either case, what will need to be established is called a null hypothesis. This null hypothesis usually will make a claim. So in method 1, that claim will be mu equals a number. Okay, so the general population equals 20 hours of TV watching a week, or whatever we're looking at. Method 2 it'll be the complement of the research or alternative hypothesis, which this is the symbol for that. And I'm about to define that for you in a second, so don't panic. The symbol for the null hypothesis is usually H0. The research hypothesis is going to test the claim. And for both methods, the research hypothesis is going to be one of three scenarios. We're either going to have, well, actually, let's do it this way. For method 2, I have it written in black. For method 1, it would be mu is greater than the number that we said. Mu is less than the number, and mu is not equal to the number. Okay? So this is method 1 in red, and then method 2 in black. Okay? So when we're doing this, what's going to happen is this first one here is called a one-tailed test high. So one tail high. Okay? That means that the rejection region is going to be over here on the top end. What we're saying is the claim that you made is false. We think it's greater than the number that you were talking about. Alright? And mu1 and mu2 has to do with method 2. And a quick side note, let's define mu1 and mu2. mu1 is the test group, and mu2 is a general population. Okay? mu1 test group, mu2 general population. So what we're saying here in the first conclusion is our test group is greater than the general population mean. And again, this is going to be your null or your research hypothesis here. Okay, and what I'll do is I'll write the null hypothesis here. So in this case, for method 1, it would be equals a number, and then for method 2, let's keep the same color schemes going that way. It's uniform. So method 1, the null hypothesis is going to be mu is equal to a number, and that's going to be true for method 2 or method 1 on all different scenarios. Okay? Method 2, however, is the complement of the research, right, or the alternative hypothesis. So that's going to be mu1 would be less than or equal to mu2. mu1 is greater than or equal to mu2. And mu1 is equal to mu2. Alright, so these are the null hypotheses for method 1 and 2 in this column above here. Okay, this whole thing right here. Red is method 1, black is method 2. And these are your research hypotheses. So back to explaining what the rejection regions were. So in this case, our claim, which was that the mean equals some number, in method 1 is being refuted by saying it's greater than that number. So our rejection region is up here, and what we'll do is we'll calculate either a z-score or t-score and compare it to a chart value of the t-score or z-score. And if your calculated mean in this case, or your calculated z-score is greater than your chart z-score, then you reject. And I'll just make this the reject column. And if it's not what I wrote over here, you will write down not enough information to reject. Okay. You can also use p-values, and there will be example videos for both of these, or actually all three of these. So just watch the examples and it'll make a little bit more sense. Now just try to see what the big picture is. So if I'm looking at the one-tail test low, so one-tail low, that would be the null hypothesis in method 1 again is still equal the number, but here we're going to say it's less than that number. In this case, the general population, or the test population, is greater than or equal to the general population, only because the research hypothesis is saying that the test population is smaller than. And either way, what that means is the rejection region is there on the left side. And all this is being based on the fact that this was less than here. That's why it's on the small side. This is greater than. That's why it's on the large side. Right? So if we do not equal to, that would be a two-tail test. My neighbor's dog is having fun out there. And basically we're saying that they equal a number, or they equal each other, the tests in general population, and the claim saying no, they don't. Alright, so here we would have a two-tailed test, and if your calculated z-score or p-value fell in this region or that region, you would reject the null. Alright? So that's the basics behind it. Now, depending on whether, if your sigma, your population standard deviation, is known, then you're going to use a z-score. If sigma is unknown, oops, forgot the N. You're going to use a t-score. Alright? So, try to understand the concept. Make sure you watch the example video. All this will make sense. I'll try to make a couple example videos, but basically you establish a claim. Method 1, you're going to say that it equals some number. Method 2, then it's going to be the complement of the research hypothesis, which tests the claim that you made. And it's going to be one of these three scenarios, and the main thing to look for is what these signs are to determine where your rejection regions are. And you're going to use whether the fact z or sigma is known or unknown to determine if it's z-score or t-score. That's it in a nutshell. I will look at each different scenario individually, so check out each concept video and example video individually. This is just an introduction to the concept of hypothesis testing. I hope things have been clarified a little bit. Practice, 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 and thank you, and have a nice day.